I want to tell you all about circles, but in order to do that, first I'm going to back up and tell you about a group of objects called conic sections, and the circle is just one of the objects in that group. The reason why we talk about this idea of conic sections is because it's based on the idea that if we take a couple of cones and we invert one of them, and then take a plane and slice, we get a section of a cone, sort of like a dissection of a cone. So if we take a plane and we slice a cone going through one side and out the base, we get an object called the parabola, a geometric object or shape. And if we take a plane and we slice it through one side of a cone and out the other, and the plane is parallel to the base, we get the shape called the circle. And if we take a plane and we slice through one side of a cone out the other side of the cone, but not through the base, we get the shape called the ellipse. And if we take a plane and slice through two cones, one inverted on top of another, and the plane is perpendicular to the base, we get a hyperbola. And so that's kind of the background on where the idea that a circle is just one of several conic sections. And why are they all called conic sections? It's because if you dissect a cone using a plane, these are the shapes that you'll get. So before I leave this discussion of conic sections, I did want to show you the algebra related to the conic sections. Down here I have the general form of the equation for conic sections. It usually starts out like ax squared plus bxy plus cx squared plus dx plus ey plus f equals 0. Now, it turns out in Algebra 2 class, we're not too concerned about this guy right here. That guy is if we have an ellipse that's at an angle at a diagonal, or hyperbola at a diagonal, or parabola at a diagonal. We're mainly concerned about parabolas that go up and down and maybe side to side. And for today, for the discussion of circles, we're definitely not concerned with the b term at all. So b is just 0. These letters A and C and D and E, those are actually constants. Those are not variables. The only variables here are the x and the y. That's it. The f is also a constant. And it just, depending on what these constants are, depending on what the value of A and C and D and E are, and F, we get different conic sections. And here's a couple things that are kind of interesting. We've already worked with parabolas, and so with parabolas, we definitely, A is not going to be 0. Because we're going to have an x squared in our equation for a parabola, and then we also have a y, and we might also have an x, and we might have an f, I went a little crazy here. That should not be x squared there. That should be a y squared right there. Let's clean that up. There we go. There we go. I thought I had maybe one too many things there. Let me see if I can pretty that up. Okay, now I feel better. So we have ax squared plus bxy plus cy squared. And again, normally in a parabola we would have just the d, the a, the d, the e, the f, and the equals something, maybe 0. Now, that was for parabolas that open up or open down. You can also have parabolas that just have a y squared and an x and a y, but parabolas don't have both an x squared and a y squared. So it'll either have an a, or either A or C will be 0. That's kind of a trick. And circles, A and C will always be equal to each other, and in fact usually they'll just be 1. A will equal 1 and C will equal 1. And then at this time I'm not going to talk much about what the values are for ellipses and hyperbolas, but I at least wanted to introduce you to this equation. We're going to see equations that look sort of like this in this form, and we're going to convert them into a form where we can quickly graph a circle.